Hello, you guys. So this homework help is for 7-2 Go Math 1 through 11. Okay. Just a second. Let me adjust this a little bit. Okay. So let us begin. Number 1, it says find the unknown value in the proportion. So I'm gonna first copy down the proportion. So it says 7 to 8 is equal to blank to 24. This one is simple. What you do is you just find the multiplicative relationship. 8 times 3 is 24. So 7 times 3, 21. Let's try. All right. Number 2. Solve using equivalent ratios. Layla and Joe are 2 partners in a business. Layla makes $7 in profit for every $8 that Joe makes. If their total profit on the first item sold is $120, how much profit does Layla make? That problem is exactly the same type of problem that we learned in class. I'm trying to find where the notebook is because I did a homework help video. That problem is just like the one that you can find on page 15 on the very bottom. The one that talks about Sheldon and Leonard's profit. Okay, Sheldon makes $2 in profit for every $5 that Leonard makes. Together, if they make a profit. So take a look at page 15 on the bottom if you need additional help. Okay? But to solve this, so I know that Layla makes $7 for every $8 Joe makes, and you want to find out how much profit Layla would make if their total profit is $120. So I cannot use Joe's profit. I can't use $8 that Joe makes. What I need to do is I need to combine $7 that Layla makes with the $8 that Joe makes to find their total profit in this situation. And I gotta use that amount, okay? So what I'm going to do is I'm going to first write $7 profit that Layla makes over, and then instead of using $8 that Joe makes, I'm going to add 7 plus 8 and put $15, which is their total profit, equal to. Now, what I want to find out is how much profit does Layla make? So I'm going to write X profit for Layla over, it says, if their total profit is 120. So 120 is the total profit. So the units match. To solve, 15 times what is 120? If you're not sure, it's 8, but if you're not sure, you can just do 120. Try dividing by 15, and then you get the factor. So 15 times 8 is 120, and so 7 times 8, you get 7 times 8 is $56. So 56. Let's try. Next one. Solve using unit rate. A person on a moving sidewalk travels 30 feet in 6 seconds. The moving sidewalk has a length of 200 feet. How long will it take to move from one end to the other? Okay, so it says use the unit rate. So I'm going to go ahead and use the unit rate. Number 3. So first I'm going to write the unit rate, 30 feet over 6 seconds. And I'm going to divide by 6 to find the unit rate, which is 5 feet for 1 second. But that's not the answer because It says if the moving sidewalk has a length of 200 feet, how long would it take? So now what I'm going to do is I'm going to set it equal to, and then I'm going to write 200 feet, where the feet is, and I'm going to look for x seconds. So 5 times 40 is 200. Now again, if you don't know, then you try 200 divided by 5 and you get 40. So 5 times 40 is 200. So 1 times 40 is 40 seconds. Now the person will take 40 seconds. Next one. Sorry. Okay. All right. We had a map that looks just like this on our notebook, on our lesson notes. We have a map here. And the question says, what is the actual distance between these two places here? The actual distance is blank kilometers. So I know that on the map distance is 9 and 5/10 centimeters. And here I have the scale. 1 centimeter is equivalent to 14 kilometers in actual distance. Okay, so you always want to start with the scale like this. Number 4. 1 centimeter over 14 kilometers. Set it equal to and make a proportion. 9 and 5/10 centimeter. So we write it on top. And x kilometer is what you're looking for. To solve, I know that 1 times 9.5 is 9.5. So then you do 14 times 9.5. Let's see. 14 times 9 and 5/10, 133. So the answer is 133 kilometers. Number 5. Complete the description. A chili recipe calls for 3 cans of beans for every 2 pounds of turkey. How many of cans of beans blank 6 pounds of turkey? How many cans of beans would replace, can be added, are needed if you were to use 6 pounds of turkey? Number 6. Oh, we have another map. Okay. Oh, the scale of the map is missing. The actual distance from West Quail to Liberty is 60 miles. So that's the actual distance, and it is 6 inches on the map. What is the scale of the map? Okay, now think about this. And then it says the scale of the map is 1 inch represents how many actual distance in miles. Okay, over here it says 60 miles is the actual distance, and that is 6 inches on the map. So what I am going to do is I'm gonna write that 60 miles represents 6 inches. And I'm going to set it equal to, because I want to find out 1 inch is how many miles. So I'm going to write 1 inch x miles. When I do that, so I'm going to solve by dividing by 6. 6 divided by 6 is 1. 60 divided by 6 is 10 miles. What that lets me know is this. It lets me know that the scale is 1 inch represents 10 miles. So 1 inch equals 10 miles. That's correct. Now there's part 2. Boston is between Liberty and West Quail and is 4 inches from Liberty on the map. How far is Boston from West Quail? Okay, so let me actually draw that out here. So Liberty. Okay. Here's my map. Okay. Now, if you look up here, we know that from here to here was 6 inches on the map, right? And they're saying that from Liberty to Boston, so from here to here is 4 inches. That makes the distance from Boston to West Quail, which is what we need to know, on the map, it is 2 inches. Okay, and then they're asking you what is the actual distance. Okay, so we already have the scale. The scale is 1 inch represents 10 miles. So we can use that to write another proportion like this. We're gonna use the scale. I'm gonna switch it over. I'm gonna put 1 inch on top, 10 miles on the bottom, just because that's what most of our scales have been. And then since I know that the distance from here to here is 2 inches, I'm gonna write 2 inches and find out X miles. And that's it. So 1 times 2 is 2. So 10 times 2 is 20 miles. So the actual distance should be 20 miles. Let's see. Here you go. Okay, number 7. On an airplane, there are 2 seats on the left side in each row and 3 seats on the right side. There are 21 seats on the right side of the plane. Part 1. How many seats are on the left side? Okay, so this is number 7. If you look at the first information, it says there are 2 seats on the left and 3 seats on the right. Okay. And then there are 20 seats on the right side of the plane. So you can set it equal to and put 20 seats on the right. And you're looking for how many seats are on the left. So it's a simple proportion. Okay, so 3 times 7 is 21. 2 times 7, 14 seats are on the left. Now part 2. How many seats are there altogether? Well, that's easy. It says in the problem that there are 21 seats on the right. And we found out that there are 14 seats on the left. So adding 21 and 14, that is 35 total seats. Right? Okay. Next one. A machine can produce 35 inches of ribbon every 5 minutes. How many feet of ribbon can the machine make in 1 hour? Complete the explanation to justify the answer. So they're actually solving it for you here. They just want you to fill in the blanks. There are 60 minutes in an hour. So instead of using 1 hour, you're going to use 60 minutes. If you notice here, they wrote the rate 35 inches on top, 5 minutes on the bottom. And they set it equal to blank inches on top, 60 minutes on the bottom because that's what we want to find out. And then you can see they're asking you, what do you need to multiply by? So I know that 5 times 12 is 60. So I need to multiply by 12. Therefore, I need to also multiply 35 times 12. Okay, now if that doesn't really make sense, let me demonstrate it here. So basically what they're saying is 35 inches over 5 minutes. I want to find out how many inches in 1 hour. So I'm substituting that for 60 minutes to make sure my units match. So then if I were to solve it, I would do 5 times 12 is 60 and 35 times 12 is the answer. That's the 12 that I'm getting right here. Okay, now, so 5 times 12 is 60. I need to do 35 times 12. 35 times 12. And that gives me 420 inches. So I'm going to write 420. And that's correct. Let me mark that here for just a second. Number 2, to find the number of feet in 420 inches, what do you need to divide by? Well, okay, so we know that 1 foot is equivalent to 12 inches. So to find out how many feet are in 420 inches, you're going to divide by 12. Okay, so 420 divided by 12 is 35. So the machine can produce 35 feet of ribbon in 1 hour. Just so you know, this 35 doesn't have anything to do with this 35 here. It's a coincidence, okay? All right, next. Oh, okay, number 9. Sorry. Marta, Lori Beth, and Ira all have bicycles. The table shows the number of miles the person rides for each of these minutes. Whose speed was the fastest? So what I'm going to do is I'm going to find the unit rate for all 3 of them. So here we go. So first, Marta, I'm going to do 5 miles in 55 minutes. And I'm going to divide by 55 to see how many miles per minute. And then for Lori Beth, it is 10 miles in 60 minutes. And I'm going to divide by 60 to find out how many miles per minute. And then for Ira, I'm going to finally do the same thing. 11 miles in 55 minutes. Divide by 55. And that would give me how many miles per minute. I know I'm going to be rounding a lot of these. Okay, so 5 divided by 55. Okay, so I'm getting a repeating decimal. I'm going to just round to the nearest hundreds. I think that would be good enough. So rounding to the hundreds, looking at the thousands, 4 or less, let it rest. So 0.09. Okay, I'm going to write it here. Because it's a little hard to read. The other one, 10 divided by 60. Okay, again, rounding to the nearest hundred, so 0.17. And then the last one, 11 divided by 55, 0.2. To make sure that my numbers have the same number of decimal places, I'm going to put 0.20. Now, the question is, which person, whose speed was the fastest? This one is 0.09 miles per minute. This one is 0.17 miles per minute. And this one is 0.20 miles per minute. So the person who goes the fastest is a person who goes the longest miles per minute. So it is this one. So Ira. Okay. Now, technically, you can also divide the minutes by miles for all of them, and that would give you an easier answer. But the reason I did it this way is I have two reasons. Number one, I want it to be consistent with the putting the distance on top, time on the bottom. And number two, I wanted you to see the rounding. But I do want to let you know, to figure out who's the fastest, you could have divided the other way around. So like you will get 11 minutes for 1 mile, 6 minutes for 1 mile, and 5 minutes for 1 mile. So obviously, taking 5 minutes per mile is the fastest. And then you could have gotten the answer that way. Okay? Number 10. Jason watched the caterpillar move 8 feet in 4 minutes. Jason says the caterpillar's unit rate is 5/10 foot per minute. Is Jason correct? So first, I need to find the unit rate. So I'm going to put 8 feet over 4 minutes, divide by 4 to see what I get. 8 divided by 4 is 2, 2 feet for 1 minute. So it's 2 feet per minute, and Jason says the caterpillar's unit rate is 0.5, so half foot per minute. So he's incorrect. The caterpillar's rate is 2 feet per minute. Now, don't forget to go to the very last one. Now, I have something. Oh, never mind. Sorry. Last problem, number 11. If the number in the numerator of a unit rate is 1, what does this indicate about the equivalent unit rates? The numerator will be less than the denominator, the least common multiple of the denominator, or the same as the denominator. What they're saying is this. You know that in a unit rate, your denominator is always 1. They're saying, what if the numerator is also 1? Then what does it always tell you about, the equivalent rates? Think about this. If I were to solve it, I would multiply 1 times 13 and 1 times 13. I would get 13 here, right? So what do you notice? The numerator and the denominator will be the same. All right. Okay, that's it. I hope it helped. Thank you.